In this video, I'm going to go through our notes for lesson 1.2. We are now solving multi-step equations. So you're going to have to do more than just one thing to get that variable by itself. Remember, solving means we're finding the value for the variable that makes the equation true. And now we've got more than one step. So a couple new things we're going to do here. We are going to do a lot of combining like terms. So you may remember that's kind of putting different terms together, combining them. So we can do that with numbers, obviously. So when we have an equation, and on one side we've got a 4 plus 3 plus 2. This is combining like terms. They're all just numbers. This would be 9. We can do it with variables as well. So our definition here, or when can we combine like terms? Okay, we can combine terms with the same variable or variables. There can be more than one when they are raised to the same power. So for example, x plus 3x. I've got one variable. They are just raised to the first power. So if I've got 1x and I've got 3 more x's, I can combine those to make them 4x. Here's an example of what we cannot do. All right, let me just actually take those away real quick so we can kind of focus. I've got x squared, or x to the second power, seen by that little 2 up there. This x is just to the first power. There's no exponent there. I cannot combine these. So if I had this in equation, they would just have to stay just like this. This is our non-example. And then getting a little more complicated, our variables here are x squared y. So that's x times y. And if I have 4 of those and I subtract 1 of those, I get 3 of that same thing. Same variables raised to the same power, so I can combine them. So we're going to do a couple problems where we need to combine variables. So in this first one, the thing that I can combine, I've got 9x on the side here, on the right side of the equation, and then I have minus 6x. So the first thing I'm going to do is just combine those two. So negative 12 equals 3x plus 15, right? Because 9x minus 6x equals 3x. Now we're going to solve this. We're down to a 2-step equation here. We've got 2 things that we're going to need to do because our goal is to get that x by itself. All right, so I'm going to have to get rid of this 3, and I'm going to need to get rid of this 15. When we're thinking about the order that we're going to do this in, it's going to be easiest to kind of work from the outside in, meaning let's leave this for last because that's right next to the x. So if we think about doing the opposite of adding 15, that would be subtracting 15. Okay, so if I subtract 15, if I do it to one side, I have to do it to the other. Okay, on the left now, if I have negative 12, this doesn't look very clear, negative 12 minus 15, that's going to give me negative 27. And on the right side, I'm just left with 3x. All right, because if I have 15 and I subtract 15, I have nothing left. It essentially goes away. Now on the right, I'm left with 3x, which we need to remember means 3 times x. So if I'm going to undo that multiplication, if I'm going to get rid of this 3, I need to divide by 3. Whatever I do to one side of the equation, I have to do to the other. Negative 27 divided by 3 is negative 9, and that is equal to x. We generally change the order here, and we'll write this as x equals negative 9. If you need to do that in 2 steps, that's fine. If you can just see it and flip it at the same time, that's okay too. Okay, in order to check our solution, I'm just going to kind of section this off here. This is our check. We are going to plug our variable back in to the original equation. Since this is just a simplified version of that, we can plug it in here too. That's fine. If we've combined the like terms, we can plug it in there. So negative 12 equals 3 times negative 9 plus 15. And we can just simplify and see if this is actually true. 3 times negative 9 is negative 27 plus 15. Negative 27 plus 15 is negative 12. Negative 12 equals negative 12. We are good. Next, same exact thing with different operations, okay, and a decimal. I would recommend just kind of trying this on your own, looking at this first example as a model, and try this on your own. So there's no combining like terms here. Again, I'm going to do this part second. Okay, so deal with what's attached directly to the x. I'm going to deal with that second. We're going to kind of work from the outside in. So I need to do the opposite of subtracting 13. So I'm going to add 13 to both sides of the equation. 2.5x equals 15. And now we're just down to a one-step equation, right? 2.5 times x. To undo that multiplication, I'm going to divide by 2.5, divide by 2.5, and you should get x equals 6. And if we plug that back in to check our solution, you should see that that is true as well. Here, I would definitely just try these two on your own. All right, this is your opportunity to try something really similar to what we just did. I'm going to go through the solutions quite quickly. So here, again, we want to get rid of the plus 3 first. So I'm going to subtract 3 from both sides. Negative 2n equals 6. Undo that multiplication by dividing by negative 2, and you should get n equals negative 3. Next, we do need to combine some like terms in part B. So I've got this negative 2x minus 10x. That's going to give us negative 12x plus 12 equals 18. Subtract 12 from both sides. We end up with negative 12 equals 6. And, whoops, I missed my x. That's negative 12. Going a little bit too fast here. That's negative 12x equals 6. And then I'm going to divide by negative 12. And if you need to use a calculator or something for this, that's fine. 6 divided by negative 12, you should end up x equals negative 1/2 or negative 0.5. Those both mean the same thing, so either way is just fine. Okay, I'm going to focus over here on the left first real quick. Okay, so one more thing that we can do, we're going to run into with these equations, is we're going to need to use the distributive property. Okay, and this is kind of our mathy notation for the distributive property. And these letters just represent potential numbers, right? And what we're looking for here is the pattern, right? We're going to see something that looks like this, and it's going to turn into something that looks like this. So remember, this means multiplication when I've got a number up against the parentheses. And the distributive property tells us that when I have this situation, I need to multiply a times that first number and times the second number, and that sign stays the same. Okay, so that's where we get AB, because that's A times B plus AC. And we can do the exact same thing with subtraction. So as an example, with some numbers and variables, if I had 5 times x plus 3, this means multiply 5 times the x and 5 times the 3. 5x plus 15. This can get a little bit tricky or complicated when we have negatives in here. I'll just do a quick example with negatives. Negative 3 times, let's just do x minus 2. So now I have a negative 3 times x, and then a negative 3 times 2. Okay, so you can think of this as a couple of different ways. Either way, you'll come out with the same result. So I'm going to do it this way. So negative 3 times x is negative 3x. I'm just going to take that negative sign and I'm going to bring it right over. Okay, so minus. Since I brought that sign over, right, I've kind of already used both of these things. I've got negative 3 now times 2 is negative 6. So I've got negative 3x minus negative 6, which we know is really the same as negative 3x plus 6. So that's a spot where it can get a little bit tricky. So moving on, when we're solving these multi-step equations, we want to look for these two things first: combined like terms and distribution. Can I do either of those things? Do I need to do that? And then once I do, then I can start using our inverse operations to isolate the variable. Meaning, inverse operations means when I have addition, I'm going to undo that with subtraction. When I have division, I'm going to undo that with multiplication. And this idea of isolating the variable, that's just kind of a fancy way of saying getting it all by itself. Okay, so just what we've been doing, solving for x or whatever our variable is. Okay, moving on. Here we need to do some of that distribution. Okay, so we're going to do that first. So I've got 2 times 1 and 2 times negative x. So this is going to be 2 minus 2x plus 3 equals negative 8. Notice when I do the distribution, those parentheses go away. And now I can combine some like terms. I've got a 2 and I've got a 3. So I've got negative 2x plus 5 equals negative 8. And now we're right back to that two-step process. Okay, I can subtract 5 from both sides. I'm going to have to move over here for a little bit of room. So negative 2x equals negative 13. Divide by negative 2. And we end up with x equals 6.5. Okay, and if that's a little quick for you, pause it, take a second to kind of get what's happening here, and then look over that again. Okay, number 4. Okay. Whenever you have story problems like this, make sure you read it and take your time, digest it, come up with a plan, right? What do we know? What are we trying to show? How are we going to attack this problem? So this says, use the table to find the number of miles you need to bike on Friday. Okay, so that's what we're trying to figure out. How many miles do I need to bike on Friday so that the mean number of miles biked per day is 5? So meaning, for the whole week, I want my average daily miles to be 5. It tells us how many miles we rode every other day. And the question is, right, how many miles did we ride on Friday? If you don't remember this word mean, that just means average. Okay, and I'm just going to kind of show a quick example of average down here on the bottom. Average means we add some numbers together. So for example, 3, if I have, let me just back up here just a little bit. If I have some data set, for example, 3, 7, 5, 2, if I have this data set and I want to find the average is a kind of middle of these numbers. So if I want to find the average of these 4 numbers, the process is just add them together and then divide by however many numbers there are. So since there are 4 numbers here, we're going to add those up and divide by 4. So I don't know if this is going to work out very nicely. I just kind of made this up in my head. 3 plus 7 is 10, plus 5 is 15, plus 2 is 17. Yeah, this isn't going to work out very well. 17 divided by 4. If we put that in the calculator, it's just over 4. So that would be like 4.2. I'm kind of estimating here for time's sake. So the average of these 4 numbers is 4.2. Okay. So let's go back and kind of think about how this is going to apply to this problem. What do we know? We know how many miles we rode Monday through Thursday. What are we trying to show? How many miles we need to bike on Friday in order for the average for the whole week to be 5. In our plan, we're going to use our equation for average because that's what we need to find. We need to find the average. So if I'm going to set this equation up, I know Monday is 3.5. I know Tuesday is 5.5. Wednesday is 0. Thursday is 5. Friday, I don't know what it is. When you have these story problems and you're trying to find a missing value, that's where we're going to put in a variable. Okay, I don't know what Friday is, so let's just put it as X for now. And my goal is going to be to solve for that variable X. Okay, so we know that we're going to take the average of these numbers. So since there are 5 numbers, I'm going to divide by 5. And when I do take the average, what should it equal? Well, the question says we want our daily average to be 5 miles. So let's simplify and solve. We can combine some like terms up here. Okay, 3.5 plus 5.5 is 9, plus another 5 is 14, plus x divided by 5 equals 5. Now this setup of this equation looks a little bit different from what we've seen now. I've got 2 things together on the top divided by 5. In this case, we're going to want to do this division first. Sorry, we're going to want to undo this division first and then undo the addition. Okay, so kind of think of, well, now that 14 is closer to the x. We're going to do that last. We're going to undo this 5 first. The real reason is because right now both of these things are being divided by 5. And so the easiest way to undo that is just multiply the entire side by 5. So when we do, we end up with 14 plus x equals 25. We're at a one-step equation here, minus 14 from both sides, and you should get x equals 11. And we could plug that back into our equation and kind of double check ourselves. But that's what we should get. Okay, you should definitely be trying these last 3 problems on your own. They're very similar to the ones we've done. You may even want to do B first because it's exactly like the average one up above. So pause the video, try these on your own. I'm going to go through the solutions to these quite quickly. So again, if you need to pause and check on your way through, please do that. Okay, part A, we can distribute, so we want to do that. So 2 times x is 2x, 2 times 1 is 2. Combining like terms, I end up with 2x plus 8 equals negative 9. Subtract 8 from both sides, we end up with 2x equals negative 17. Dividing both sides by 2, you should find that x equals negative 8.5. And again, to check your work, just take that 8.5, negative 8.5, substitute it back into our equation. You could even just go here because we've just been simplifying up to that point. And as long as it's equal, then you are correct. Again, I'm going to jump down to part C. We've got some distribution to do, negative 13. Okay, we've got those negatives in there. So I've got negative 2y minus negative 8 plus 3y. We can clean things up by combining some like terms. I've got a negative 2y and a positive 3y, so that's just 1y. And minus a negative 8 turns into plus 8. Subtract that 8 from both sides, and we end up with negative 21 equals y. And again, we generally flip that around to be y equals negative 21. finally, this is exactly like that problem up above. So how many miles would you need to ride on Friday so that the average number of miles per day is 4? So it's going to be this exact same equation, except we want the average to be 4. So 3.5 plus 5.5 plus 0 plus 5 plus x divided by 5 equals 4. And again, very similar. We're going to end up with 14 plus x on the top divided by 5 equals 4. Multiply both sides by 5. And we end up with 14 plus x equals 20. Subtract 14 from both sides, and x equals 6. So in other words, if we want our average miles per day to be 4, on Friday we would need to ride 6 miles.